Hi everyone. In this video we're going to work on another basic differential equation applied to a jet trying to take off. So here we have a 727 and we know that it needs to reach a speed of 200 miles per hour if it's going to take off. Oh my God, it's early. If it can accelerate from 0 to 200 miles per hour in 40 seconds, we need to know how long the runway is going to be. We get to assume acceleration is constant. So we basically know that we want our final velocity. Again, you don't have to use this notation if you don't want to, but it's kind of handy. Should be 200 miles per hour. And our final time should be 40 seconds. And notice right off the bat that we have a little bit of a units issue. So I think I'm going to try and fix that. So if we look at this as, you can choose which way you switch, but generally feet per second is what I tend to prefer. Okay, so if we want feet, we're going to say there's 1 mile in 5,280 feet and 1 hour 3,600 seconds. I can crunch through at least some of this. Here we can do better than that. Cross out 100 and then 18 times 2 is 36. And then we could even do 9. Half of this is 2640. That looks like about as far as I'm going to get by hand. 2640 over 9 feet per second. And, let me see. Check what that is. 293.33. Whoa. 33 feet per second. Okay. So we know we want our final velocity to be about 293 feet per second. We want that to happen after 40 seconds. We're looking for the length of the runway, so we want to know what the final position is going to be. Okay, so it can accelerate from 0 to 200 miles per hour in 40 seconds. So we need to figure out our acceleration, and it is constant, so that should make it easier. We know that the velocity increases by this 293.33 feet per second in 40 seconds, which means the acceleration, 293 over 40 is about 7.33 feet per second squared. I don't know if it actually, I don't think my screen capture is smart enough to show you my calculator. It's not very exciting for this stuff anyhow. Okay, so we've got our acceleration, which means we can start working on a velocity function. Oops. T. And then we need plus the initial velocity. And a lot of times people mess up here, and that's one of the reasons it's good to label things ahead of time. They want to put the 200 here. We're actually starting from 0 miles per hour, so this is 0. Our final velocity should be 293 feet per second. And then we can start on our position function. Kind of wishing I left things as fractions right about now. We divide that by 2 again. Too early to do mental arithmetic. It's about 3.67. T squared. And then plus initial position, which once again, people sometimes get mixed up by, but here, initial position, we haven't gone anywhere. So we're saying whatever our starting point is, how long does the runway need to be after that for us to get our speed up to 200 miles per hour? So we initially haven't gone anywhere at all. Okay, so now we have all of our functions. Our goal is to find a final position, but in order to find a position, we need to know a time. And in fact, I think we were even given the time. We know that it's 40 seconds. I was going to go looking for it, but we've got it. Often in these problems, if you're not given that 40-second part, what you'll have to do in between is set your velocity function equal to your final speed to find the time. And sometimes on a problem like this, I see people do that little bit of extra work, and it's fine, it'll get you there, but we were told that this needs to happen within 40 seconds. So if we do S of 40, these are really all approximate, 3.67 times 1600, calculator side work again. I have a sneaking suspicion that if I just stuck with my decimals that were looking kind of messy, this wouldn't have been so hard to do by hand. 5,866.67. Okay. And I'm keeping my previous answer in my calculator, so if you do calculator work for a project or something, just make sure that you keep as much of the information as you can so you're not getting a bunch of rounding error. So it's 5,666.67 feet approximately. That's fine, that's an answer. I'd also say that it's really nice if you try and convert these answers into the most reasonable form possible, the one that seems most useful. I would actually say that miles might be good here, so this is fine. I don't think it's a bad thing, but that would be one thing to consider. So we could go back in and we could divide that by 5,280, and we get 1.11 miles. So I'm certainly not going to mark you wrong for not converting that, but it is maybe a useful form. Okay, I'm trying to think if there's any wrap-up stuff I want to say here. No, I just think it's really good to do some of this labeling up front and make sure that you're aware of what's an initial and a final velocity or something in between. Thanks for watching. I'm going to go drink coffee so I stop yawning in my videos.